Hello, my name is Valenzuela and I'm presenting this work entitled Expression Transfer using Flow-Based Generative Models, whose main goal is to generate deepfake content by transferring facial expressions between identities. As we all probably know, deepfakes are synthetic media in which a person in an existing image or video is replaced by someone else's likeness. This is known as identity swap, but this is just one of the many possible types of deepfake content that we can have. For example, here we have an illustration of attribute manipulation. In this case, we are turning the hair color from dark to blonde, and this is also considered a deepfake. In addition, in the recent years, we have seen that flow-based models are emerging in deepfake creation, since they build on invertible transformations. In this work, we present a method for deepfake generation based on facial expression transfer using flow-based generative models. Our approach relies on simple latent vector operations similar to the ones used for attribute manipulation, but for transferring expressions between identity source-target pairs. So we start from the pre-trained glow model together with additional sets of 20 images of the identities involved in the transfer. From now on, we will refer as source to the identity whose expression is going to be copied, and as target to the identity whose expression is going to be modified. As I have already mentioned, we perform manipulations in the latent space as it is done in attribute manipulation, but in our case, we consider expressions. That is, we take the latent representation of the source identity, which is this component here, and subtract an average latent representation of this same identity, average over the small sets. This gives us an expression vector that we add to the average latent representation of target identity after rescaling it by a factor alpha that controls the size of the expression transfer. As we have seen, the Z bars are average latent representations and they are computed as pure means, as we can see here. They correspond to mean phases, which are defined as the expressionless phase of an identity. Therefore, in this expression here, we are modifying the expressionless image of the target identity by means of the expression vector, that by definition only contains the facial expression of the source, getting rid of the source identity component. This method does not require full retraining of the glow model, just requires taking averages over small sets of images of both source and target. Here we have a representation of the entire method. We give as input the original image of the source with the expression to be transferred, and we also select the target identity. Then we compute the mean phase images for both the source and the target with the small sets. Here we have chosen the target identity for illustrative purposes, but the same goes for the source identity. Then with this information, the two means and the original expression, we can apply the proposed equation in the latent space. And of course, in the output, we'll obtain one output image for each alpha value. We start considering an alpha range between 0 and 1. Nevertheless, in this work, we also present an evaluation pipeline of the generated images that shows that the alpha range should be narrowed down to some value between 0.3 and 0.5. Due to time limitations, we cannot present the evaluation pipeline today, but I encourage you to check how this range has been obtained in the paper. Let's see an illustrative example of a transfer with this narrow range of alpha. Here we can observe the results for 5 different expressions between two popular identities. This first column corresponds to the original images with the expression to be transferred. This second column corresponds to the mean phase of the target identity, while the other images correspond to the target output images for increasing values of alpha. We can see how the expression of the mean phase of the target is modified across the alpha range, acquiring the source facial expression. From these findings, we can conclude that expression transfer using flow-based models is feasible following our proposed approach. In particular, we have found a valid range of values for the parameter alpha between 0.3 and 0.5 that controls the expression transfer. Of course, we need to perform more experiments to validate these first insights, but this work represents a first step in deepfake creation by expression transfer in flow-based models, providing an initial pipeline for both generation and evaluation of such type of content. Thank you very much, and if you have questions or comments, I'll be happy to address them either by email or by any other channel. Thank you again.